Hello, everybody. My name is Jelani, and welcome back to the ninth episode of the DeSci Rising series put on by DeSci World, where our goal here, as always, is to provide an opportunity for many of the wonderful projects on our ever-growing DeSci World dashboard to kind of formally introduce themselves, update their progress, highlight their achievements, and just generally engage with both the DeSci World and wider DeSci community. Now, the idea behind all of this is that at DeSci World, we very much believe that more than the tech, more than the funding, it is the community using these tools that will usher in many of the changes that we are looking for decentralized science, DeSci, to bring to the various legacy STEM industries. Now, with all that being said, in today's episode, we're actually going to be much more heavily focused on the tech perspective. And that is because I have the very great pleasure of speaking with David Thompson, who, for those of you that don't know, is actually one of the original creators of the first Bitcoin ATM and is also the founder and CEO of Grassland, a project developing a peer to peer computer vision software that gives any internet connected machine or smart contract a complete awareness of real life and non digital environments. And so, with that, David, thanks for taking the time to be on here with us today and break down, hopefully to an ELI 5 level, exactly what is being built at Grassland.
Thank you, Jelani. Thank you very much for having me here. It's been a pleasure getting to know everyone there at DeSci World, and I'm looking forward to continuing this discussion.
Oh, I'm sure this is going to be a really good discussion. So, disclaimer for those of you who are interested in learning more about what Grassland is doing, I pinned one of their tweets that gives a link to their ELI 5 breakdown of the platform. So, feel free to go onto their website, which is very nicely done, and read about what they're actually doing. And so from our end, David, how I like to kind of start this off is to kind of just give an allow you to give your introduction, what your history is, how you came into this space, and like what you've been up to leading up to this point.
Sure. Yeah. So again, my David Thompson. I'm a mathematician and programmer. So I've been in I guess the crypto space for over a decade now. I started some of the first Bitcoin meetups. This is back in Ottawa, Canada, and then around that time, some friends and I built one of the world's first cryptocurrency ATMs. That was 2013. We weren't the first. I think there was two before us that earlier in that year. But yeah, then afterwards, so after working on that, that would have been 2013. I started working on some math and AI problems that intrigued me. It was about, let's see, about then around 4 years ago. I was asked to if I could help Facebook's AI lab in Montreal solve the problem of how to give AI an intuitive understanding of the laws of physics from its own experiences. So this was like 4 years ago, and what we knew what was coming was that AIs were able to generate very convincing images of people, like photographs, and very convincing types of artwork and music, and obviously this was a few years before things like DALI and Stable Diffusion, right? But you could see the progress that was coming, and of course here it is, right? And so these those applications like DALI and Stable Diffusion, they really show how an AI can develop this intuitive understanding of, for instance, art without being taught art in the way that, you didn't have to like program it. It would just look at examples and then get develop this intuitive way of being of knowing what art looks like, or what, you know, a chicken riding a motorcycle looks like, right? Um, and so what they asked of me back then was, how can we do this with like the real world, like the laws of physics? Because, so for instance, you and me as human beings, we develop an intuitive understanding of the world since we're babies, right? Like you could take a 10-year-old child and you could throw a ball to them, and they will look at the ball moving through the air. They will calculate the arc of that ball and position themselves to catch it. Now, that kid is not doing calculus in their head, but somehow they intuitively know how to position themselves where that ball is going to be. They're doing this naturally. And so how can we take that and give machines a way to do that? Um, and so what I knew the problem was actually a math problem. It wasn't like it was fundamentally something that was just in the way that we defined um, our sort of our geometry. And so what I realized was that so essentially, let me give you an example. For you and me, human beings, our perception is sort of limited. You've got two eyes and one brain, right? And so, anything in front of you. So say you got, a computer in front of you, a desk in front of you. You can see that from one perspective. But if you could say you could take out one of your eyes, pull it out, stretch the optical nerve, so you could look at, say, your desk or your computer from both sides at the same time. You'd have this sort of perception of the world where you could see things, from all sides at once. Now, of course, everything else in the room would be blurred because of the limitations of your brain. But if your brain could adapt, you could see it from both sides. Now, imagine though if you had a much more flexible brain and you could handle signals from three or four eyes, then you could position eyes all around the room where you'd be able to see things from all perspectives at once. Now imagine if you had a brain that could handle, an infinite number of eyes. You'd be able to perceive everything, so nothing would surprise you. You'd have this perception of the world where it would be as if everything was flat. Because you know how when you look at like a piece of paper, a drawing, or say a photograph, it's a two-dimensional image.
Right.
And so, we're three-dimensional beings, like we sort of have this three-dimensional perspective. So we can see a two-dimensional object as if all sides are turned to us, right? But if you could imagine if you had this sort of perception where kind of existing in like four dimensions, then you could look at a three-dimensional object in the way that we look at two-dimensional objects, where you could see it as though it was completely flat, relative to your scope, right? And so what I sort of do with that is um, I there's this concept in mathematics. So this actually I wouldn't even go that far. It's referenced a few times on Wikipedia on its concept called scope. And so what I did is I took this sort of I created this new geometry. Now you know how with everyone learns in school you have the Cartesian plane, you have an x and y coordinate or x, y, z, however many dimensions you want, but you always have a single origin. So what I did is I created this geometry where what the transformation of this geometry was is that you could get an infinite number of origins, right? So, that the origin is essentially the point in the center, of course, where your X and Y lines meet, right? And so with that, you'd have this infinite number of frames of reference, but they would all sort of be in one sense operate the same origin, but you could stretch them as far as you want. Um, and then I took that concept I sort of elaborated on that, took this concept and tied it back to the fundamental theorem of calculus, which is, of course, the relationship between, the derivative and your integral, right? Essentially, I won't get into too much detail. You can read more about it on little ELI 5 there. But what it meant was that what I was talking about with this and this new concept, this scope that I was elaborating on, and then the fundamental theorem of calculus was that they were both actually talking about the same thing, but in different ways. And so with this new geometry, essentially you could um, have an intelligence that could have complete awareness. It would be able to perceive the world, understand the world, but in a way that we would never be able to as human beings because of the limitations of our brain. Um, but there's a lot more. I'll get into it as we go along. But I'll talk about like the implications of how you implement that in software. But yeah, that's sort of where I sort of started from.
Absolutely. And I know, you and I have had a chance to speak about this before, and it really did take me reading that ELI 5 to kind of understand exactly what you mean. But in my own mind, essentially, like what you said, right? You're creating a means, or you're changing the paradigm such that we can conceptualize, or we can build something that can view all almost like an omniscient eye, right? If you want
Mhm.
to, relate it back to like Sauron or something like that, you kind of have this perception, this multiple observer perception of a given object or a space, or essentially space time in and of itself.
Yeah.
Um, so that's really interesting. How does so then I mean, as you kind of led into it, how do you so as a concept, because that's a concept, how do you actually translate that into something pragmatic or practical from the software perspective?
Yeah. So one of the things that I realized, like once I was trying to put the software implementation together, that like to satisfy those requirements, you'd have to fulfill three conditions, right? So it would have to be trustless, meaning that the entire system would have to be designed so that it'll always work in the way it's supposed to, even if the entities that it interacts with in the real world aren't trustworthy, right? Um, and then anti-fragile. So that would mean that because over the real world has things like, attacks, there's volatility, there's stressors. That's a natural part of the real world. And because, you're trying to give a machine or an AI an intuitive understanding of the real world from its own experiences, well, you'd have to make it so that its discernment would improve as a result of experiencing the tax, volatility, stressors, all those things that are natural parts of the world. So, so yeah. So the first one, trustless. Second one, anti-fragile. And the third one is interesting. It's more about game theory. It's essentially you'd have to, uh, since this AI, um, this system would provide any AI that sort of uses it a self-perpetuating advantage because you have this sort of complete perception, right? Or this sort of at the limit, of course, right? As you expand, um, it would it would allow this, any AI or any other connected object that uses it to walk through and experience, you know, uh, any event or people's entire lives or the life of any object or from all positions and perspectives and timestamps. It would be creating sort of what we call a prisoner's dilemma. I won't get into that. You could look a bit more on that, but essentially, if we elaborate a bit further, um, it would be what we call a strictly dominant strategy. So in game theory, a strictly dominant strategy refers to a situation where one player has superior tactics, regardless of how their opponents may play. So, for instance, if you look at like say a chessboard, um, or like or I'll give like a much simpler example, right? Say, you have a particular game like tic-tac-toe or something like that, and you have there was a strategy that you came up with that gave you a dominant advantage, right? In any situation. Those games aren't really those good examples there, but um, there's certain games that you can play, certain strategies, certain situations in which a player can have a dominant strategy so that no matter what any other player does, they're essentially controlling the situation. And so with that, I knew that if I designed it the way that the math was dictating, my calculations were dictating, then you'd have something that was sort of open source because it didn't need to not be open source, right? And free because essentially the AI would be giving its data away for free, and it also paying you to mine it. And the only restrictions are the laws of physics. So you have a system that gives you sort of complete perception um, liberally, right? It actually encourages you to use it, and it gives it away for free, and then pays you to mine it as well. So actually, sorry, I sort of got ahead of myself there. I should mention how it pays you. So what I needed to do for that, I created a new type of proof of work. So you know how like with a regular proof of work, you have a system that takes in a block, a number of transactions, um, calculates, runs a series of hashes. I'm assuming we all kind of know what hashes are, and then produces a hash with a particular pattern. But Grassland, of course, I had to kind of go back to first principles and think of and reason about how this was going to work. So again, I mentioned trustless, right? So what I did is I made it so that you know how in an artificial, so just to catch everybody up, in an artificial neural network, you have a series of what we call neurons. And these are just basically think of them as like an array of numbers. And every time a set of numbers sort of gets, is input into the system, this array of numbers gets multiplied by that input. And then what comes out of that is another set of numbers. And this happens repeatedly. Okay, they get moved along and you get these, this sequence of calculations. And so what I did is instead of hashing just the block, like a bunch of transactions, what I did is I created a separate blockchain that would run alongside this system. So again, Grassland has one blockchain with transactions, but what it has also is this blockchain that is essentially a blocks of all these activations, these calculations that were passed through that neural network. So whenever a video frame passes through Grassland's artificial neural network in any of the clients, those frames, the activations, the calculations that get done that determine what's in that picture, or sorry, what's in that frame and what this environment looks like, all that information gets hashed. So with that, we can now prove that that a user had used this neural had run this is running the video frames through this artificial neural network because that hash is sort of a marker, or it's essentially a way that you can't a marker that you can't fake, that proves that they actually perform these computations. So if you could take a random set, you could request from them a random set of a random set of their inputs, and anyone can take say a random sample and pass those frames through their own neural network because everyone's using the same one. And if they get those hashes, the exact same hashes that the other person declared that they got, then they know that that individual was running that neural network, performing that computation, running it on their GPU because and essentially it proves that they did that work. So with that, we have you have a system that not only shows, of course, that the detections that they got, the information that this perception that they were viewing through these video streams was run by this artificial neural network, or processed by the neural network, but it also prevents things like spam, because you have this sort of barrier wherein in order to get information into the system, you have to pay a cost. You're paying something. And what the AI does, what the software does with that data, or with this whole process, is it allows the system to produce this tamper-resistant history of the real world, because all those outputs correspond, all that data that's in the network corresponds to a bunch of different hashes, and these are hashes from each individual. And so you create this system where it becomes, I'll get into more into that later, but it becomes computationally harder and harder to put fake data into the network, because essentially you've got to produce so much computation that in order to a lot more computation in order to actually put fake data into the system. That'll become
Right.
clear a little bit later.
Yeah, right, definitely. And I know, that particular concept of, and I'm going to kind of cheat sheet it and say, reading that ELI 5, that concept of being able to see past and future at the same time based off of this new geometry it makes it seem like, introducing, as you put it, intractability into it is obviously going to it's going to weed itself out. Like it has a self-filtering mechanic in it.
Yeah. And going back to that, like seeing not just like three dimensions as if from all perspectives at once, but because it's a blockchain and you've got this sequence, right? So you're not just talking about, perceiving all things at once through space. You can perceive all things at once through time. And I don't mean us in that sense. I mean this whatever machine that you're training this data on, whatever, whether it's autonomous vehicle, a drone, some sort of statistical, like an analytical system. It actually can see through time as well.
So that's a really interesting point because as I hear you break down what exactly Grassland is building. So one, it's a blockchain. So you
Mhm.
built yourself a new blockchain that is actually predicated on the tenets of what we as Web3 actually want, right? The
Mhm.
trustlessness, anti-fragility, and I forget what the third axiom was. Remind me what the third
So
axiom was?
it would be like a prisoner's dilemma.
Exactly. So incentivization to play like correctly.
Hmm. Yeah.
Um, but it also seems like you've built in like the whole premise of having this computer vision, this intake of real world data into, this machine digital environment almost seems like you built an oracle. Like it also has a built-in oracle aspect to it.
Mhm.
Is that
Yeah.
also true?
Yeah, oh, definitely. So the other part of it is like the way the nodes get paid, they're not paid just essentially according to their computations. That's sort of the bare minimum to sort of get your data into the next block. They're actually paid according to how well their observations help other nodes predict what they're going to see. So if you think about it like this, imagine you and I are standing at two ends of a street, right? We don't trust one another. Say we're like, I don't know, we're doing traffic analysis or something like that. And say we just met, we're not sure about, each other's, how good we are as scientists, essentially. Um, Now, if I say to you, if I, send you a message saying, okay, what you're going to, I just saw a yellow bus, right? And it's headed, of course, down the street. And then if a few seconds later you observe that yellow bus, right? Then I've made a prediction from your perspective, and you've confirmed that prediction, right? And if I'm continually doing that, and what I say, the observations I make become accurate predictions for you, we don't need to trust one another. You don't need to trust, my academic qualities, my integrity, my ethics, or anything like that. You could just use simple mathematics and go, well, statistically, how could, if David was making random predictions, then you would not be seeing the things that you'd see, right? If you were observing, if what I was saying, like the cars that were coming your way, you were actually observing it. Because over time, you would just need to look at the mathematics, the statistical improbability of from that for me to be making random, if my observations were completely random, that the things that you would be seeing were, that you'd actually see them, right? Does that make sense?
Absolutely. And I think,
Yeah,
to frame it better, when you mean you or I, you're actually talking about the observer, which in a practical sense would be the software or the object, whatever you're training
exactly.
to learn based off of this
Yeah,
neural network is doing. So if you have
yeah,
an example being machine learning, if you're telling it like, expect this, that because it
yeah,
has the perception of being able to quote unquote move through time repeatedly and like continuously see this thing happening, it builds the statistical power to say, okay, this is true versus something that would stop at some point during its playback of whatever happened.
yeah. Well, you have to think about it in terms of like in a decentralized way, right? Um, like, for instance, like, you and I, we have a brain that's composed of, trillions and, millions and billions and billions and trillions of neurons, right? But then in one sense, we think of it as just one brain. But with Grassland, you have an arbitrary number of cameras, essentially, or some sort of, whether, it's like a thermal camera or an optical camera any number of sort of sensors, and you look at these each of them as or the I guess the software client that's connected to them as an observer, um, and so what we would have done here is sort of taken the same concept that we've understood in science, where we have peer review, right? So I produce a paper or something like that, and then you take that paper and you try to reproduce it, right? There is my experiments, right? And so you can prove that, what, or you can, demonstrate what theorem that I'm presenting. And that's what I've done. I've sort of taken that concept and then applied it, algorithmically and given it to these AIs that are perceiving the world so that they can essentially peer review one another. And they can, in a way that, well, that makes it, a trustless system. And by rewarding them based on how well their observations help other nodes predict what they're going to see, that creates an incentive system, and that allows those to keep, well, incentivizes them to expand, to keep giving this AI, this sort of decentralized system, complete awareness of the real world. Because underneath it all, what Grassland has is a map of the world. And so what it's doing is each software client forms part of this decentralized AI that incentivizes its expansion across the globe by paying miners to reveal all the dark areas on that map of the world. By dark, of course, I mean it's like if you've all played any real-time strategy games, StarCraft or like games like Civilization, like when that part of the map that's dark is a part that you can't see, right? So that's what I mean.
Right. So, and I was just about to get to that. So, we're talking about the um, conceptual infrastructure, what underpins this whole network, but what is the application layer? So on Grassland, it excuse me, it your website talks about how you're trying to almost like debunk, not debunk, but get rid of, like, overtake Google Maps in terms of developing this means of looking at the entire planet or revealing the map of the entire planet. Can you go into, like, what the actual premise of that? What's the point? What's the use case?
Sure, I guess you could say that, like in one sense, it's I guess taking over Google or kind of competing with Google Maps, perhaps. But in this case, like you'd have, the coordinates for people's, bodies, right? You have the coordinates for a car, in real time. So that is like tremendous, implications, right? And I don't mean like just like, okay, their position, but as you keep growing, you have like this, say the coordinates of their limbs, right? So their arms, legs, the coordinates for, all these different sort of details on these features of the natural world. And by doing that, right, you can create things like, so as I was mentioning there, so let's say with self-driving cars, imagine like for a self-driving like yeah, autonomous vehicle, one of the things that they sort of struggle with is being able to sort of perceive, well, again, it goes back to my original point there, that when we think about, or when we do make these implementations of, say, any type of robotics, we always implement it in the same way that their perception, in the same way that we as humans have become used to. And we take that for granted. We're like, okay, well, I see from one perspective. Well, that's, obviously that's the best way to do things. Um, but we forget the fact that, machines, they have these very, very, with, robotics with computers, their brains can be very much more adaptable, right? They're not limited by what evolution has given them. And so instead of putting the camera on the car, it's decentralized, right? You have this sort of perception that gives them awareness all around the corner. So if you're, for you and me driving along, we're sort of when we're driving, you're making predictions about where is this car ahead of me going to turn. I pull up at the light. What is this pedestrian going to do as they cross the street? And and our brain is sort of mapping this out. But imagine if you had this awareness where you could see everything that's going on around the corner. You could see everything that's going on on the car in front of you, the car in front of them, in front of them, in front of them, to the right, to the left, almost inside of buildings, where you could make predictions about when somebody is going to leave this building, what their schedule was, because you've been building up this sort of data set of these commutes, people, what they do, where they go. You can, this is of course later versions of the software. We're working on this actually with some 5G stuff, where you'd be able to things like eye tracking, so gaze tracing. So, for instance, we take this for granted as human beings that that example there where you're at a stoplight, a pedestrian's about to cross in front of you, maybe you're going to make a right turn. You can tell that that person's not paying attention to you. because they're looking at their phone. But maybe a self-driving car might not be able to perceive that just because of the sort of occlusions that are in the way. But with what I'm talking about here, you could perceive like exactly where they're looking, and you could know where if they're distracted. You'd also know a lot of the history of this person, right? And you could build off of that. You're not just looking at things from one perspective. You're seeing things, you're looking at things backwards through time as well. So you've got this ability to make these predictions in real time about really uh, detailed and really interesting and relevant aspects of the environment. And so you can perceive things and make those predictions about what's going to happen in a way that a human being could never do that. And so, of course, that applies to drones as well, or any type of, say, AMR, autonomous, any type of autonomous mobile robot. But the other thing that when we were sort of implementing it, I didn't really realize how useful it would be was live building occupant counts. Um, that's for like you can imagine if you're like a firefighter, and you're or any type of emergency services worker, when you arrive on a scene, like the first thing you want to know is okay, who needs help, right? And where are they? What is their situation? And so this is actually something we were working on with this Australian company a few years ago during the forest fires that were there. Like imagine if you know, okay, you arrive on the scene, you know how many people are in this building. Okay, there's 5 children in this building. There's no one in this building, right? There's people here that are trapped in this other building, and that allows you to make extremely intelligent decisions, and be able to solve problems, being able to help people, because you're always dealing, of course, with limited resources, whatever you're doing, and you know exactly what to do in every situation. That gives you complete awareness there. Just knowing how many people are in a building, imagine what that does for things like law enforcement. Um, when you arrive on the scene, and having a system that is, and you can tell how computationally hard it would have been for somebody to fake this, to fake that information as well. So that is just hugely important. And then the other thing, of course, as we got into it, is analytics. So we all know things like Google Analytics or Mixpanel or a number of these analytics. Actually, we're using Twitter right now, and of course they have analytics systems that are looking at how we scroll, right? What do we click on? How do we respond to changes in the UI? They do things like A/B testing. Now, when we looked at what we're doing here and like the implications of that, because essentially what we're doing is we're bridging the real world with the world inside your computer. So you could take that and make analytics about the real world, in the same way that you would take analytics and like determine how much people scroll or how they engage with your app. You could look at that and say, okay, how do people engage with the real world, and make these applications on top of that, to whatever you're trying to do, increase user engagement in some way, or analyze traffic. I mean, that's a given. But then if you look at things that sort of we'd never been able to think about before, um, are just how people behave in all kinds of different environments, where we don't have that sort of data or that way of modeling it, um, and this would give you this sort of perception of how people, um, um, what cues, whether those are like cues from the sort of the natural environment, I guess you could say, or from other people, and how those cues influence whether it's consciously or subconsciously, the way that we behave in all kinds of different situations.
Yeah, so I'm gonna I'd like to circle back. So there's a few points I want to touch upon, but to kind of give a high level, it sounds to me um that essentially you're building a smart AI, right? Like a true definition of a smart AI, something that can learn indefinitely. It can actually learn from through perception of everything that's going around with it, everything about humans, and inform us on things that we really might not have known like a depth of data and kind of self-reflection that we weren't aware of before because we didn't have that infrastructure that had this objective view of what we did, right? Um, so it's an interesting concept. It's an interesting concept, but the one of the points that I wanted to circle back to, David, is the granularity level. So you mentioned that, perceive, I conceivably, because internet and these sensors, our phones, our TVs, our smart TVs, and all these objects are present in almost every environment that we inhabit. There's a level of granularity there that kind of makes it almost all-seeing. To go back to the all-seeing perception,
Mhm.
right? Like, kind of
Mhm.
gets rid of the concept of privacy.
Yeah, that's the thing. So, like I was saying, like all this, my whole goal with this was just to solve that problem, right? They said, can you solve this problem of giving AI an intuitive understanding of the world? And I didn't set out to like, okay, we're going to remove privacy. I didn't set out to do anything like that. I was just like, okay, it's just a math problem. I'm just solving it, right? And of course, it's like with any problem. So say you have like a quadratic equation, you're going to have say two solutions, right? So you could have like a positive and negative answer, right? And in this case, yeah, there's going to be, not to be corny with the analogy, but there are positive and negatives to this whole thing. So the the implication of like say that sort of reduction in privacy is that of course the way I saw it was that okay, well, a lot of the times the way that we think about that is that privacy is essentially, or surveillance is a very the problem with it is the asymmetry of it, right? Where you have some person that knows a lot about me, and that's where the danger comes, right? Where I don't know a lot about them, they have a lot of power over me. Um, so, like, imagine if you were you're impaired, right? You were blind. Anybody who can see has power over you because they can see you, but you can't really see them. Um, but if you think about like the way this problem was had to be solved, fortunately we live in a universe where that corresponded to a sort of a symmetry, right? Where in order for you as a whether you're a company to or just acting in your own self-interest, where you're mining this system or you're running this software, Grassland software, whether you're building a third-party application to do analytics on people's behavior, or you're taking that data to build a robotic system, anything like that. Underneath it all, of course, fundamentally is just a model of the real world. That's it. What you want to take and do with that information, that's up to you. You can do all kinds of different things, whether you're, you know, uh, you know, rescuing people or analyzing them for marketing or something like that. I was just trying to solve that problem. Um, but then the other side of that, of course, is you have a system where I can't really do anything to you in a unilateral way, because if you know everything about me and I know everything about you, it's mutually assured destruction if I do something negative or you do something negative to me, right? Because there's no way that we can escape. It's like we're both inside the same computer system. Um, that the entropy, the uncertainty that was between us, is getting reduced over through time, right? It's becoming smaller, or that entropy, that uncertainty is getting smaller and smaller. So I'm sort of obligated, in that sense, to behave in as altruistic a manner as possible, if I have any form of self-interest.
Right. And by, you or I, are you talking about people who are, let's say, interacting with the Grassland platform or the software or, the network? Or are you talking about the AI itself?
I was talking about like people, not just people, of course, that are just interacting, but people that are who who are inside of it, right? Whether you're completely what you'd consider a user or not, right? If you're just aware that okay, there's this thing that exists, and my everything in my life, everything I have is it's on this blockchain. Um, then from whether for every individual from their own perspective, their own frame of reference, acting in their own self-interest, you're, well, that sort of changes how you behave, right? Or I imagine that would change how you behave. But that's more of like a, psychological thing. People are very random, but there's always, once you have a system where you have like this indelible record, that, you're inclined to sort of take stock and so, okay, well, how do we treat other people, right? But remember, this is a decentralized system. There isn't like one person who sort of is an exception to that. If whether it's us that could, whether this technology is out there, right? The so-called, the genie's out of the bottle. Um, it'll, whether it's us or somebody else as they continue on or different implementations of this, right? That exists, right? And so, but then from that's from like a human perspective. From perspective of an AI, that is an interesting question, um, because you have an AI that is essentially emulating people, because that's what you're doing, right? That's what it's doing. It's like you're taking you're observing a person, then it's creating a digital version of them. So it is emulating people, and it's learning to make predictions about what they do and how this thing that they do, corresponds or allows it, makes, inclines them to do this, right? With, predicting their behavior. Then you're like, okay, well, if you're talking about, say, now remember, Grassland itself is just creating a model of the real world. It's not really trying to create anything else. It's just trying to follow just trying to predict what's going to happen and observe. Um, and then, but whether it's Grassland itself or like say other third-party AIs that sort of take this data and train themselves on it, they're training on human behavior. So I mean, I don't want to say that. I don't want to like make predictions because this is a system where it's what we call it's a complex system. What mathematicians would call, well, essentially complexity theory. You probably remember it from an aspect of it from Jurassic Park, where Ian Malcolm was talking about chaos theory. That's just one aspect of it. But these are systems that are essentially unpredictable, where you're dealing with a system where there's a lot of different components and they're all interacting, and they are what we call sensitive to initial conditions. So it's like the butterfly effect, right? So it's very hard to predict what the implications of this are, because everyone, like, we're always discovering people coming up with new ideas, right? About how they would implement this. And so it's really hard to say where this will go. um, However, we can say that we know that at least saving grace is that, we have it's essentially a system of accountability, right? Because if you're doing this whatever you're doing in the real world, right, the system is incentivized to observe that and to share that with other people.
Right. Um, and to that last point, I think there was a few gems that you did drop, but to that last point, I imagine that, all your concept of, mutually assured destruction, data symmetry, which I think is the third postulate or axiom of the actual software
Hmm.
of the theory. Like, I imagine that regardless of that point, there, as humans, there's a level of privacy that we all enjoy or we all value, and that's differing, but especially government bodies or national level bodies. I imagine that, they're like, what have you had have you had any interactions
Yeah, that
with these
is
government entities?
this is where the conversation gets really interesting. So yeah, it was about, I think, over a year ago. We were sort of, well, I realized that what this thing was becoming, um, like, you got to remember, in the beginning, you're just writing code. You're just writing one line after line, right? You're just trying to solve one problem each day, right? You're not really, sometimes you don't really have the time to like sort of step back and look at the implications. You're just like, okay, I'm just solving a problem. I'm just solving a debug math problem, or I'm just solving a programming problem. But then you sort of realize, okay, well, wait, when you add things up or you look at, the people that are using the software. And I was looking at like it was funny because in the beginning I didn't really think that there would be a lot of government agencies that would have any interest in what we're doing so much, or that they would.
Really?
That, well, it's hard to say
That's
because
the
it was like
first thing I would have thought.
you have a decentralized system, right? And I was because you know how like because like I spent so much time around with Bitcoin and crypto and cryptocurrencies and all that, and it was sort of they have like it's a very rebellious sort of thing, right? It's a very anti-government sort of thing, and so but it was really hard to say what was going to happen, and then we had a lot of our users were people who worked for the government, and then I sort of realized that as we kept growing, as things happen and you look at like the implications of like what you could do with this, it's like, yeah, this is um it was I sort of realized that I had to make contact with not just uh, defense contractors who were using the software, but actually like actual like government like Department of Defense agent like three-letter agencies, um, because I didn't like the one thing that is consistent, whether your intelligence gathering system is an AI or your intelligence gathering system is a human being, a human controlled organization, is they both hate surprises. They want to be able to predict things. And I realized that, you know, if as one thing leads to another, they are going to be, if I don't let them know that this thing exists and assure them that I was only trying to solve this problem for um for this AI lab at the University of Montreal there, um uh that that they would I wanted to make sure that they knew that we weren't that that how could I put this in a way that I don't want to I don't want to listen to this later and realize the way I worded it wrongly. I just wanted to make sure that they knew that we were trying to, we weren't bad guys. Let's just say that, right? We're just solving problems. We're just solving math problems, right? And so, like, it wasn't a threat to their AI, their intelligence gathering system. And in fact, ironically, just the opposite. It's kind of it was kind of a strange issue because it's not really hard. It's hard to have precedent for something like this, um, because you know you could interpret a grassland one way, or you could interpret it in a completely different way. And so, yeah, that's interesting. And so that's led to a lot of interesting conversations that I've had with them.
Right. So, in the attempt not to get ghosted or suicided, uh, can you like not so in essence you are having conversations with
Oh
certain
yeah,
three-letter agencies who are interested or who have already been
yeah.
using the software in some form.
Yeah. Like they, obviously they're not going to tell you a lot of what they already know. But, they, as far as I know, they really like they like what we're doing. Um, and so, yeah, that's good. Um, but in a sense also that's sort of scary, right? Um,
Yes.
then so they you know so I made this post on Twitter. I made this post on Twitter that we talked to the U.S. Department of Defense there. We had a meeting with them back in the summer. We showed them how to mine, showed them how to. Do we have a soon? Eventually, we're also going to be implementing this feature, which is what we call bounties, where you could actually use the UI, draw a perimeter around any part of the map, and use your wallet to place a bounty on any region of the world that you want. And that will essentially pay bonuses to any miners who are going to, for any miners that created, produce a digital twin of the people, places, and things within that perimeter that you drew. So that's very interesting. But of course, this all goes back onto the blockchain, right? So whether you're whatever you're using that for for uh, sort of national security purposes, or whether you're using it for for that, or whether or I should say that even if you're using it for those purposes, you could also be using it for your say your Tesla, right? So say Tesla wants to get have their cars have complete awareness all around San Francisco, right? They can set a bounty on whatever all of San Francisco or some borough of just to start. Yeah, that itself has profound implications, and so we're just trying to think through that, and then of course what it is that we do as the core development team in order to make sure that we are sort of behaving and doing things in a way that you know allows make sure people are protected, right? And no one gets hurt, and how much we can do, because there really isn't much precedent for this, right? Like there's obviously precedent now with especially with crypto with financial regulations, and we're seeing that a lot more. But there isn't really anything. I've never seen anything like this before. So we had to kind of figure what the precedent should be, um, and from our game theory calculations, or just from what they think are they're going to want. Yeah, and so that's one of the big challenges.
I mean, this definitely sounds like a pivot point in the history of man from perspective of technology, similar to, Robert Oppenheimer and all these kind of things, right? In your, to quote you, what you said earlier, you've opened what could conceivably be a Pandora's box, and now we're just waiting to see what the fallout of that is actually going to be. Now, as we round off the top of the hour, I do want to open the floor to people who may have questions to David about applications of Grassland, and so please feel free to request. But I have a few questions myself. Um, so in the meantime, as people become unshy, an example of this, I wonder, is there? So can you put in a retroactive data into this to help speed up the machine learning? So the reason I ask is I'll give a specific case. So Ed here, who's in our speaker, he's a farmer, and so application of this software, application of this machine learning in the context of crop yields and farming and food agriculture. If I was somebody who had historical data on my land, on the yield and all this kind of things, would it be possible for me to upload this into Grassland and then kind of get like an output that might be able to foretell what to expect on crops? Like, is that an application that
Um,
can be?
yeah, I think eventually, as the system gets like we start getting more and more like detailed, um, sort of a detailed model of the real world. Yeah, I think eventually that should be pretty much something that would definitely be able to do. But like when you say like upload that in the Grassland, I wouldn't like if you're talking about putting that onto the blockchain.
Well, what I mean is
No, I mean
as an input for, because in essence,
yeah,
you're also building like like a really fine-tuned prediction engine. And I
yeah,
could be
yeah.
wrong from this, but like whatever input that can be used to make those predictions, could that set of, let's say, agricultural data, meteorological data that spans backwards retroactively be put into the framework of Grassland to then yield out
Yeah, yeah, for
kind of
sure. Like
prediction?
what I would do is you would take the data set, like the blockchain, and then I wouldn't do this on chain, but yeah, you would take it and put into like another, combine it with this other type of data, like your data, your specific, like say, uh, some like you'd have to crunch those numbers and produce some like abstractions, and then make those predictions. Yeah, you could definitely do that with, and Grassland's data would help you. Yeah, absolutely. But this is as the software matures, that would definitely be a use case for it. Absolutely.
Great, good to know. Ed, you're up. Feel free to ask a question if you want to.
Yes, this is really interesting. Um, yes, I come from regenerative agriculture, and of course, where we came from is we're working with nature. And so in the past, conventional ag was pretty much wipe out nature and then feed the plant. And so I could see how AI can work really well in considering the variables in agriculture compared to, let's say, a typical factory situation where we think of those situations as complicated, where we think of what we do as complex. And we see the difference in that. And so if you were to, let's say, even in the grassland sense, work with a regenerative farmer, what we're trying to understand is, what do we have to really understand? And so we're collecting data incredibly deep, now getting even to metagenomics and, epigenetics. And I mean, we realize that it is an incredibly complex system. But yet we still have to try to figure out how we can understand it and steward it. So when we get into those kind of systems, and of course that includes a lot more senses. I mean, I have a farmer friend that's been doing this for a long time. He is unbelievable with his nose. You can hand him a handful of soil and he can tell you all kinds of stories with his eyes closed. So it's the complexities that I get concerned that, I think AI eventually, but in the meantime, the problems when it isn't able to deal with complexity is really concerning. And in agriculture, we realize that, and we're scared, of what the reductionist system that just looks at things as complicated has caused and what they're even thinking about in the future. Thank you.
Yeah, that's really interesting. Especially with nature, of course, like the natural like nature's default is uh complex. And what I mean by that is like complexity theory. We have a lot of interacting components, right? And sort of the downside of the way that we think about things, we think about things in a very Cartesian way, which is one origin, one frame of reference, right? And but the problem is that that's just sort of an illusion. We sort of perceive the world from our one single perspective, and we try to model things like that. We try to model nature, make predictions about weather, crop yields, and all those kinds of things, because that's the way we think. And human beings have been doing that for a long time, right? Like we used to think that we were the center of the solar system, right? We used to think that everything was controlled by some entity, right? Like there was a god that controlled the harvest, Baal, right? And there was a god that controlled the weather, and Zeus and there was always like some central authority. We think in that way, and I mean, even though we don't, think about that, use gods to like predict the harvest or whatever. Now we still think of things in the same way, where there's a central sort of frame of reference. We still model things in that way, and that's when things that are complex become complicated, because we just can't model. We're just not thinking about them correctly. And so that's really where what I wanted to do, we had to do. And I could see how this, like for agriculture, crop yields, those types of things, is that when you have a system that takes in the sort of perspective, or the all those different components, and models how they interact together. So whether you're talking about the weather itself, you're talking about the crops, how they grow, the soil, all these very, very it's an entire system of things, and looking at it as a system of interacting components, and trying to understand the patterns, and being able to see, okay, what are these patterns going to tell us? What is going to happen next? So of course, if we can optimize it, this is exactly what Grassland is designed for. That way of viewing the world, and I don't want to use the word holistic. I guess you could say it like that. But yeah, looking at it as a sort of a system that it's very hard you can't reduce this. It's very dangerous to sort of create very sort of reductionist models. You have to kind of create a very big a bigger model with a lot of interacting components and consider how these things sort of, I guess you could say, communicate with one another, and what those things do what they can tell us about agriculture, right? About nature.
For sure. And I think, this concept of complexity and the one reference frame, complexity versus complicated.
Complicated, yeah.
Right.
Complicated, yeah.
And viewing something maybe not holistically, but comprehensively, right? So Ed talked
Mhm.
about it from the perspective of agriculture. Caro here, who's listening, who is a part of one of the core members of DeSci World, she's a marine biologist and she studies dolphin patterns. Um, and so as it relates to that, so essentially this grassland engine, and it's not the right word, but I'm going to call it like that. The grassland engine, the predictive engine, the complexity viewing, the multi framework, the multi referenced frame engine. It's almost seems like it's like it can be used as a complementary um, brain
Mhm.
to help humans better understand their
Mhm.
environment. And so I'm a
Mhm.
neuroscience, a neuroimmunologist by training, and so the reductionist approach to things like genetics and people who do genetic editing and all these kind of things, and people trying to, gain of function is a very taboo word, but doing changes at the genetic level and seeing how that propagates at the more complex stage, like that's been a very difficult thing for us to do as humans, as scientists. And so having some, and that's partially limited to our reference frame. And so having this engine, this grassland engine that I think can be applied to this to give us more of a comprehensive, if not holistic view of what could come out of this. Obviously with
Mhm.
time, right? With iterations of time where it can learn, I think it's going
Yeah.
to be a supremely powerful tool.
Yeah. And like fundamentally what's going on like underneath of it, it's like your what we're taking from like just a camera sensor. So whether that's a thermal imaging, thermal camera, which of course, great for all kinds of different applications like in nature. And then, for optical cameras, what's coming out of that is just basically a wave function. So it's a very natural, fundamentally that's just a probability distribution, but it's just a wave essentially. And that can be applied, that can receive as you can take this sort of that underlying technology there and apply it to a lot of different things in nature. Like you don't, what I mean by that is you eventually wouldn't have to just need, it wouldn't just be cameras, right? Anything that can produce you with sort of a signal, because that's what it is, right? And then having this system that takes in signals, um, uh, and from all these different perspectives, and then combines them into and collapses them into one sort of um, uh, model of the world. Yeah, that could there's so many different areas in which in nature where those where you could apply that. Not just from what I'm saying is trying to say is that eventually you wouldn't just need camera sources. You could take all kinds of different inputs.
That's amazing. Um, and I would love to spend more time. Actually, anyways, I would love to spend more time. And David, honestly, the next time I drive up to Ottawa, I might just hit you up for a beer to continue this conversation if you have
Actually,
time.
yeah, I'm based in Toronto now.
Okay, so next time I
Yeah,
jump over the provincial
yeah,
boundaries to
yeah,
Ontario and see where you are in Toronto, then I'll give
yeah.
you a shout for sure. But as we've reached the top of the hour, and I think all the questions have been answered, David, I'd like to thank you very much for taking the time to speak with us. I think it's been a really good introduction to what grassland is, very much the tip of the iceberg of what I think this gigantic rabbit hole is going to lead to. And as I spoke to you before, as I said to you before, I'm going to reiterate now. I'm definitely going to be keeping an eye on this. I think there's a lot of interesting um, fallout, if I could say, is going to come out of this, and it's groundbreaking. It sounds groundbreaking to me, and I very much appreciate you taking the time of kind of incorporating us and letting us be a part of this the beginnings of this groundbreaking movement.
Thank you so much. Yeah, Oh, my mic on? Yeah, it is. Okay. Yeah, thank you so much. No, it's been a pleasure. I've really enjoyed it.
Great, great, great. So everybody, thank you all for listening. Ed, it's always great to have you here, Carol, and everybody else who's left. So for your own information, David, this is obviously being recorded. We will be taking this off of Twitter eventually and putting it up on YouTube to enhance people's perceptions. People can have and listen to this conversation over and over. We will be, tweeting it and promoting it to get more eyes on Grassland because I think this is definitely things that people need to be aware of. Um, and I can see, I'm already like fathoming how this is going to change, science, not even just DeSci, but the concept of science or the things you can do as this program matures. So with that, again, thank you everybody for listening. David, thank you again for coming, and I hope you all have a great weekend. And I will see you next week for episode 10 of DeSci Rising. Bye,
Thank
everybody.
you.
Bye, David.